Hi everyone, I am Chandan Purohit from Satvik Softech. In this video, we'll be seeing how to use the Raylib library to build a very simple game using the C language. Let us dive straight into the code.
Okay, so let us get straight into this task of building a simple game using the Raylib library. Let us first open the official documentation of the Raylib library. So here is the website, the Raylib website, and you can check out the examples. This is one of the ways which I follow. This is a technique which I follow. In fact, many developers follow the same technique. You just go to the examples folder, examples section here. You'll find lots of examples. Let me just start from simple chase or simple ball like this. Okay, so here we have a moving the ball with a mouse. Here we have moving the ball with input keys. So I'll just take this example. So here he's move the ball with keys. Okay, so I'll just take this code. The code is already given here. Just take this code. Okay, so if you take this code and you try to run it in your computer, you should be able to do it. And you just copy paste this code into my editor, open a new file. So I'll say a simple ball game or something like that. Ball game.c. Okay. So in this, I'll just paste the code which I had copied. We'll get into what exactly is happening here, but before that, let me try to run this and see whether it works. It should work actually. So this was the way we compiled the program in the last class. So this is the ball game. Oops, I think I missed it out. So this is in a different folder, I guess. Okay, so I just have to shift to a new folder because so videos, game dev, and then in that Satvik game dev. Okay, so here we have the ball game. So now we can compile the game. Okay. So the game has been compiled. To run the game, we have to again give a path to the Raylib library. So here is path LD library and all that. You can just copy this if you want. And okay, so we have the ball, and I am able to move the ball with my keyboard keys. Okay, the arrow keys. Press escape to exit. Okay. So now let us get to the code. The code is quite simple actually. If you are able to read this. So here he has made use of two constants, the screen width and screen height. We can change this and see how the output changes. And there is a function called init window. Okay, so this is used to initialize a window, as the function clearly says. You can go into documentation and see exactly what it does. So here he is initializing the screen width, the screen height, and he is giving a title to the game output window. And then there is a vector2 structure which he has declared here. So this is the variable, and initializes it with the width and height of the 50% of the width and 50% of the height of the screen. So that is the ball. The center ball is positioned at the center. So once the ball is positioned using this vector, okay, it is not yet positioned, but we have the current position of the ball stored in this variable. Okay, then he is saying we set the game to run at 60 frames per second. We don't touch this. It runs at 60 frames per second. And this is the main loop. This is where all the action is happening. So while window should close, so there is a function called window should close. This function, okay, as the comment says, it detects for the window close using window close or the escape key. Okay, so if that has been pressed, then it returns a true, in which case the loop exits. If the loop does not exit, then it gets into this loop and it updates the screen. It's almost like rubbing off the entire screen and redrawing it. Okay, so here he is checking for every time he is going to check which key is down. So if the right key is down, then the position of the ball is updated by 2 units, you can say. The same thing, if left key is down, the ball's position, this x value, is updated by -2. That means move to the left. So the Raylib library also uses the famous coordinate system, which is plus in the right direction. Okay, x is plus in the right direction, minus in the left direction, but the down, y is plus in the down direction and y is minus in the up direction. That is a little bit different from the standard Cartesian coordinates. So y is positive in the down direction here. So the ball will move down. Okay, when you press the down key. So in that case, the ball's y position is incremented. Okay, when you press the up key, the ball's y position is decremented. That's what he is doing here. And then the ball's position is changed. This structure value has changed. The content of the structure has changed. But we need to draw the ball actually. So we'll start drawing. Begin drawing is a function which you should use to start drawing on the canvas. And then every time you need to clear the background. Okay, so here you can give which color to use to clear the background. Here there is a ray white. Ray white is a color for white. Okay, it is defined in this .h file, raylib.h. Okay, then a draw text is another function which you can use to draw a particular text at a particular location on the screen, and the color of the text is given here. Finally, you draw a circle. Draw a circle using a vector. So draw circle V is a function which draws a circle using a vector. The vector is this ball position, and this is the radius of the circle and the color of the circle. This maroon color is also defined in the Raylib library, raylib.h file. Then you end the drawing. So each time in the loop, it is going to do the same thing. It is going to check whether you have given arrow key input, and then update the vector, and then clear the canvas and draw the ball again based on the vector. Okay. So once you exit the loop, you close the window. Close window function which helps you to close the window and the OpenGL context. Okay. Fine. So that is fine, but let us try to change a little bit. So for example, we need to do some simple changes. This is how you learn actually. So you do some simple changes. First, let me just show you what is the current output. If I run this, now you will see that the title, this is the window title, Raylib core example keyboard input, right? We'll just change this title of the window first and see how it works. This is the title. This is where the text is. I will change this. I will say something like the simple ball game, and then run the program again. Sorry, so you should again compile the program because you have changed the source code. Execute the program, and now you see that the title of the window has got changed. Okay, fine. So So this is the title. You can change the screen width, screen height, and also see how the things change on screen. Now let's make this a little bit more interesting. So here is checking for key down, key up. Okay. What if I want to keep the ball moving always? Okay. So that should also happen. Let me just comment this part. If I want the ball to keep moving, I just need to update the vector each time. Okay. So how to update the vector? The ball position is the vector. If I say ball position dot x plus equal to 2.0f. Okay. So this should make the ball move in the right direction every time. Fine. I think that should happen. Let us try this out. So now the ball keeps moving in the right direction and it goes off the screen. Okay. So as expected. So let us get the ball rebound. Okay. After hitting the right screen. So if I want that to happen, I need to do a little bit of calculation. So what is that calculation? So just to show you, we will open a diagram editor here. So I can say diagram editor 9. Let me just open a diagram editor. We can open any editor actually. It's taking some time. Okay, so I just decide later. So if you have a screen like this, okay, I'll just take a box. If I have a box like this, and if I have a ball inside which is a circle, if it hits the edge, okay, if this hits the edge like this, in this case we need to calculate when it has hit the edge. So if you look at this code, what he has done here is that the ball's position is fixed here to screen width by 2 and screen height by 2 initially, and then he keeps moving the ball. The screen width is also fixed, it is at 800. So if I say that this is 800, the width of the screen is 800. Okay, so this is 800. Oops. Is this the text should get inserted below the, so I'll just say this is 800. So that is the width of the box, the rectangle, and this is I think 50. The radius is 50. Yes, this is the radius, this is 50. So that means when the ball hits this, what about the position? The position xy, the ball's position xy. Okay, so I think this is the center of the ball. Okay, the position is the center of the ball. If that is the case, then the ball hits the walls of the box at how much? 800 minus 50, so that is 750. Okay, when the ball hits this edge, the center will be at 750. So if I check for that condition, I think we should be able to get the rebound. So all of this should happen inside the while loop, because every time this while loop gets called, so you update the position of the ball, and then check if uh, if the ball position dot x um, what can I say, plus 50 is greater than or equal to the screen width. Okay, so if it is greater than or equal to the screen width, here we should start changing, just like we should start subtracting. If the for the rebound to happen, we should subtract the position every time, x position. So okay, we need another way, we'll probably need another variable here. It is better like you take another variable for the direction. This is the direction, the int direction equal to 1. Okay, so this is just extraction, actually we'll talk about that later. Then I say direction, okay, direction equal to direction star minus 1. So I am multiplying by minus 1 because in this we have to reverse the current direction. Actually, in this case we are checking only for the right wall hit, so I can just say direction equal to minus 1, and here instead of saying plus equal to 2f, I will say plus equal to direction star 2f. Okay, I think this should work actually. Let me just try this out. Okay, compile. There is an error, semicolon expected. Okay, we'll just have a semicolon here. Compile again. You run. Now the ball is moving, and yes, we have a rebound. Okay, so but we have not handled the hit at the left side of the box. So let us do that now. We are reversing the direction to minus 1 on hitting the right side. Okay, the same thing we can do for the left side. This having 50 as our having 50 here directly is not preferable. Actually, we can have another variable here, something like a const int radius. Okay, radius equal to 50, and then instead of 50 I can put the radius. That is better actually. Okay, and here we can also change this from 50 to the radius. Okay, now this here we have handled the right side click, right side hit. Okay, what about the left side? We can go ahead and have a else if ball position dot x. So left side is handling left side is a little bit easier, because if it hits the left side, and get back to the diagram, if this ball hits the left side, in this case, well, this is 0 0. If you observe the coordinate system, this is actually 0 0. Okay, so we are at 0 0 here, and if the radius is 50 and the ball hits here, the position of this is exactly 50, right? The x position of the center of the ball is 50 when the ball hits the left side, right? So we just need to check for that. So ball dot position dot x is less than or equal to the radius of the ball. If this is the case, then I reverse the direction again. Direction equal to 1. Okay. If we do this, I think the ball should keep on rebounding left and right. So we have a right hit and then the ball moves. Let us see whether it hits the left. Yes, there is a rebound. So the calculations were correct. Okay. So that is about the left and right rebounds. It is so easy, right? We have made use of the if else in C, as you can see here. We can do a little bit of improvement here. Instead of having if else like this, we can simply handle this with, I think we can handle this with a the AND operator or operator, sorry, either this or this. In both cases we have to change the direction actually. In both cases we have to change the direction. So I just say direction star equal to -1. So if this works, that will be good. So now we have a right hit, rebound, and then it is moving to the left. Then there is a left hit, rebound. So we have the calculation is correct. Okay. Okay. So now we are handling left and right rebounds. In fact, this direction is actually the x direction. So this is the x direction. We also need to do the same thing for the y direction. So instead of taking two separate variables, we can have another structure, vector structure actually. So we'll say a vector 2. This is a two-dimensional vector holding the direction, and then I'll say what? So this is the starting value, right? So we'll say 1, 1. So this is the starting value of the structure. X is 1, y is 1. So it is like saying you want the ball. See, if the ball is moving like this in the horizontal direction, what's happening here? If the ball is moving straight, that is okay. The ball is moving like this. So what is actually happening here? In this case, the x value is changing, y value is not changing. Okay. If the ball is moving horizontally, the x value changes, y value does not change. If the ball is moving vertically, the y value changes, x value does not change. If the ball is moving like this, then both are changing. So in this case, x is increasing, y is also increasing. So in this case, the y is increasing, the x is decreasing. In this case, if you observe, okay, let me do that again. In this case, if you observe, the y is decreasing, x is also decreasing. Okay, so we can handle these things straight away using the direction. So now instead of saying direction star, we can't say direction star because the ball's x position can be changed based on the direction, x direction. Okay, so now it should be direction dot x and then direction dot x. Okay, the same code should work with the structure now. Oops. Okay, conflicting types for direction. Previous definition of direction was here. So there is a int direction which we have to remove. Okay, we'll remove the previous line int direction and then we'll compile again. Now it is ready. We'll run. The ball is moving again. It hits the right part, rebounds. Now it's going again. It is going to hit the left part. Yes. Okay. So that's fine. Now let's get back to the code. In this case, if you observe here, we are only moving in the horizontal direction. What about moving in the vertical direction, right? So we have to move in the vertical direction also. So I'll just say ball position dot y plus equal to direction dot y star 2.0 f. Okay, but we are not yet handling collisions in the y direction. but let us first see whether the ball moves. Okay, this is how you need to start learning. Okay, this is how people learn to code. You need to make small changes. You need to come up with your own changes and think and try to get the work done. Okay, you need to read documentation also. So the ball is moving now. Okay, but it has gone beyond the screen. So why did the ball move in this direction? Because we have given the direction vector here as 1 1. Okay, so it is moving in the down direction. If you are not comfortable with this, you can change. For example, if I say the ball has to move in this direction, -1 1. -1 1 means the ball moves in the negative x direction and down. Okay, so let us run the code again. The ball should move in the negative x direction and down. Now the ball is moving in this direction. That is what was expected. Okay, so let us handle the rebounds for the top and the bottom layers of the box, the window, sorry. So we'll do the same thing. So instead of changing x, now we'll handle for the y. That's all. So if the y plus radius, so if you observe this diagram, the ball hits the top part. Okay, this value, the center of the ball is if you look at the center, this center will be at some value of x and the y will be 50 or less. So y is 50 or less. If it hits the bottom, the y will be the y of this value plus 50 will be greater than or equal to the height. Okay, so y of this, the y value of this center plus 50 is the radius, so plus 50 will be greater than or equal to the height of the enclosing box. We will handle the condition here. Ball position plus radius if it is greater than or equal to the screen height. Okay, if it is greater than or equal to the screen height, the ball's y position is, if the ball's y position is less than or equal to the radius, okay, in that case we need to change the direction y. Okay, now we should, I think we should be able to handle the rebounds. Oh, sorry, we need to compile again. Okay, so the ball is moving, there is a rebound, hits the left top, again down. Okay, so now we have a bouncing ball which is bouncing in all directions, right? Fine. You can change the speed of the ball if you want. So the speed of the ball can be easily changed to something like this. We are changing the direction, we are changing the position based on these values 2f, 2f. If you increase this, the ball is going to move a little bit more. So if you say 5f, it appears to be moving faster. Okay, so let us try that just to verify. 5f and 5f. So now you will see that the ball gets displaced a little bit more every time. See, so now the ball is moving a little bit faster, right? So what is actually happening is the screen is getting redrawn, and every time the screen gets redrawn, the ball is again drawn at the current position. The x and y values are changed and the ball is drawn. Okay, now let us take this a little bit further. So we have a ball which is rebounding everywhere. So let us make this game into a the platformer game where you have a ball and the ball hits a a platform. If it rebounds only if the ball hits the platform. Okay, if the ball does not hit a platform, then you have lost the game or something like that, right? So let us do that game. So in order to do that game, first we need to draw the rectangle. So let us get to the Raylib library. Here the cheat sheet is present. Okay, we'll go to the cheat sheet. We will now see how to draw some shapes. Where is that shape? I think we need a rectangle actually. Rectangle. Okay, so there is a shapes module. Here you can have a rectangle. Draw rectangle. Okay, so there is a draw rectangle V based on the vector position of the rectangle and the size of the rectangle, and you can give the color of the rectangle, right? You can either do this or you can use this. There is also a rectangle structure, I guess. It has everything. Either you have two vectors, one for the size, one for the position, or a single rectangle structure like this. Where is the rectangle structure actually? Rectangle structure. So there are some predefined structs here. There must be a rectangle struct. No? Okay, yeah, we have a rectangle struct here. Struct rectangle, but we need to see what should be inside the rectangle struct. Okay, so how to get that now? I think it needs 4 values: left corner xy and width and height. I think that should be how that should be the case. So let us try first. We'll just draw a rectangle. See. Okay, so we have a rectangle. This is my platform, and I say xy, right? Xy, width and height. So xy, we want the rectangle to be at the bottom. So the xy should again be center. We can place it at the center like this, right? The same thing, we'll take the same thing from here, put it here. This is the xy, and I want width and height for the rectangle. We want a rectangle which is just a little bit more wide, and the height of the rectangle is a little bit less. The color of the rectangle can be brown. I think brown is defined here. There are colors defined actually. Colors: blue, black, white, blank, brown. Yes, brown is there. So it should work. Okay, so we need to put a semicolon in the end. And then we'll draw the rectangle every time. Begin drawing, clear background, draw text, draw the circle, and then draw the rectangle. Draw rectangle. The documentation says that to draw the rectangle, what else do we need to pass? Where is it? Okay, so draw rectangle rec. It takes the rectangle and the color. Okay, so we'll call the draw rectangle rec. It takes the rectangle, which is the platform, and the color, which is brown. Okay. I think this should be okay. We can't pass the brown here because it takes only xy, width and height. So we should see a rectangle now. Let us run the program again. Okay, so we have a rectangle here which is positioned at the center now. Okay, because the xy we have given at the center. If you want it to get positioned somewhere here in the end, in that case we need to again properly position the rectangle. So let us take this to the end. Where is it? Oh. So here x can be the same, but y should be something like the screen height minus the height of the rectangle, which is 13 in this case. If you do this, the rectangle should come below. So now you have the rectangle below, but we need a wider rectangle. This rectangle is not that wide. We need a rectangle which is more wide, right? So let us increase the width of the rectangle a little bit. Where is the width? This is the width. Okay, so it is better if we define a constant here. That's not required, I think, because it is used only here. Okay, so we'll increase the width to say 150. So I think this should be enough. So now we compile, run. Now you have a rectangle which is wider. Okay, so now we need to handle we need to make sure that when the ball hits the platform, only then it has to rebound. Okay, it should rebound here everywhere, but as far as the below part of the window is concerned, it should rebound only when it hits the platform, right? So let us do that now. So how can we measure that, whether it has hit the platform or not? So in that case, so let us get to the diagram here. Here you have the ball and you have a platform, small platform here. Okay, so this is how platform is. When the ball comes and hits the platform, we need to calculate this part. So the ball can hit from anywhere. It can hit like this, like this, like this. From any direction it can come and hit, right? So we need to find out a common pattern, mathematical pattern here. So when the ball hits the platform, okay, can hit. If it hits like this, then if it hits like this, the ball should not rebound. Actually, the ball should not rebound. The ball should rebound only if it hits like this. Okay, it should hit like this. So anywhere like this in between till this part, right? When the ball hits the platform, how do we measure that the ball has hit the platform? Okay, so we can do some calculation here. The radius of the ball, this is the platform xy. The platform xy is at this edge point xy. The radius of the ball, this is the center of the ball. Okay, so if we look at the position, the geometry here, we should be able to get a pattern. This is 50, right? 50. The ball is inside. We can say that the ball is inside by checking the x value and the x value of the center of the ball. So x value of this and the center of the ball, if we check, then the ball, it can be 50% like this, less than 50%, less than 50% is something like this, right? Okay, so the ball can come and hit in this direction. If it hits like this, we can't do much because the ball has touched the below part. If the ball touches the below part, then there is no rebound. So we can say that the x value of the rectangle and the x value of the center of the ball, if we subtract the remaining value, if it is within 50, right? Well, can we say that the ball has hit? What about the y value? The same thing we can apply for the y value. If we subtract the y value, if it is within the radius, that is 50, then collision with the platform has happened. If both have occurred, but the ball can collide here also, it can collide anywhere else actually, so that those things cannot be handled. In this case, what can we do? You can say that the ball has come within the region of influence, something like this. You can define a region of influence for the rectangle. Okay, so this is the region of influence. Okay, this value is x, this y, sorry. So if the ball reaches within the area of influence, so it has reached within the area of influence in the y direction, when you take the y of the rectangle and the y value of this, you subtract, and in that case, if the value which remains, it is less than or equal to 50, then ball has come within this area of influence of the rectangle in the y direction. Okay. Next, there can be another area of influence in the x direction. So if the ball comes here, it has hit the rectangle. Now it is in under the influence of the rectangle. Like if I say that the x value, x plus the radius of the ball, if it falls within the x value of the rectangle and the x plus width of the rectangle, I think that should work. Yeah. So x value of the center of the ball and x value of the rectangle. Okay. So let us do that now. Where is it? Yes. We have the updating of the ball here. So in this case, the ball hits the ground. Okay, in this case, the ball hits the ground. When it hits the ground, we are changing the direction. Okay. Let us handle hitting with the platform, right? So if it has hit the platform or not, let us check for that. It is better to write a function actually. If you write a function, I think the code will become a little bit more easier. We are messing up a lot. We can have a function which tells us whether the ball has hit the platform. Okay, something like this. You can say that we have a function which returns an int. So platform hit. Okay. So platform hit, it takes the ball position, it also takes the rectangle position, the rectangle itself, it takes the rectangle, it takes the ball, both are okay. This ball position is a vector actually, vector 2. Rectangle is a rectangle, type is a rectangle. So return value is true or false. We can make use of a bool here, but I'll just stick with int for now. So platform has been hit if the ball position dot x plus the radius of the ball. Okay, we need another input here, radius, the radius, int radius, no yeah, int radius plus the radius of the ball is greater than or equal to rectangle dot x and less than or equal to rectangle width. Okay, rectangle dot w, width and height. I think w is the variable they have used, xy wh. So width plus x plus width. Sorry. So rectangle dot x plus rectangle dot width. So in this case, it has come within the x inference. It should also come within the y inference. So we have to handle for that, and I'll take it down, and the ball position dot y, plus the radius if it is greater than or equal to the rectangle dot y. Okay, so I think this should work. If this is the case, then return 1, then the platform has been hit. Otherwise, return a 0. We don't need an else, just say return 0. So I think this should work. Every time we need to check whether the platform has been hit. So if the platform has been hit, we'll put it here actually. So the ball has to rebound only if the platform hits, right? So okay, we'll comment this line actually. We'll add another if the platform has been hit, we need to pass the ball position and the rectangle platform. Okay, let us see now. Oops, so lots of errors here. Expected semicolon, rectangle. Okay, rectangle has no member named w. I think it should be width. I guess if it is not w, it should be a width. Let me change this to width and see. Width, okay, you don't need the height. Let us try to compile. Okay, so that's gone. So it is width. Expected semicolon before the return statement, line number 17. Okay, so there semicolon is required. Okay, too few arguments, we need a radius also. Okay, so radius is to be passed. We pass the radius here. Compile again. I think it should get compiled now. Yes, run it. So, see, ball is moving. What is happening here? Okay, that is interesting actually. Let us take the rectangle to the left actually. There is the rectangle position, initial rectangle position. Let us make this is the ball, this is the rectangle, screen width by 2. Let us take this to 10. So the rectangle should move left. Oops, what is happening here? Okay, so collisions, upper part collisions Okay, we have commented that line actually. So we need to handle the upper collision to the upper part only. So if it collides to the upper part, then reversed direction dot y star equal to -1. Okay. But the platform hit is probably not working properly. It's not working, but the rebounds are happening. Get it again. But when the ball hits the platform, how do we make it rebound actually? Because the direction. Okay, so again we have to do a little bit of geometry here. When the ball comes down like this, it hits the platform, it should move in this direction. Okay, what does that mean? So the ball is increasing its y, increasing, y increasing, x decreasing. It hits here, y changes, x keeps on, x is as it is. So x is as it is, only the y changes, right? So every time if it comes down like this, y is increasing, hits the platform, y is decreasing. So direction changes, y direction changes when the platform is hit. Okay, so I think the same thing we have written. When the platform is hit, the direction, y direction should change. Okay, the x direction should remain as it is. So that is not an issue now, but the platform hit is not working properly actually. Let us print these things and see whether we can do something. We can print this out. Ball position x plus radius, ball position x plus radius, that means the ball positions x value plus the radius, x plus radius should be greater than or equal to the x value. The ball comes like this and it hits like this. Okay, so it is actually okay. Minus 11. Fine. So the problem here is that x value for the left part ball position dot x plus radius is greater than or equal to rectangle dot x. Ball position dot x minus radius should be less than or equal to the rectangle width plus the rectangle x. Okay, I think that was the problem. Oh, that's not expected. That was interesting. So the ball hit. Okay, so because the ball hit here, when the ball hits the bottom, we have to end the game, right? So when the ball hits the bottom, there is no point. So how do we say that the ball hit the bottom? There was the condition. Where was the condition? Okay, we have deleted that. So in the ball position, we have to break out of the loop. Here, if the ball's position if ball position dot y plus the radius, if the ball position dot y plus the